Hello, this is Nitin Dahad with the Times, and I'm here today with Sanjay Kumar, who's a former senior director for the CHIPS program. Sanjay, hello.
Hi Nitin, pleasure to be here. Thank you for the opportunity.
Well, thank you. We're in this lovely environment in Santa Clara, and
Yes.
I just wanted to sort of tap your knowledge about some of the things you've seen, both from the perspective of what's been good with CHIPS Act and what other things have been achieved, but also maybe some perspectives on where things will be going in the semiconductor industry. So let's start a little bit with what your role in the CHIPS program and what you feel is the impact of that CHIPS program.
Thank you Nitin. I was a senior director on the team. I was in the investment team and I reported to the chief investment officer, and our role was to evaluate the application for the funding, work with the applicants throughout the process leading to the PMT and then finally leading to the design award document. So we worked on mega deals, medium-sized deals and small deals.
Okay, PMT means what?
Preliminary memorandum of terms and condition. So that's non-binding. This is like dating, not the marriage.
Okay.
And so design award document is the marriage.
Okay, interesting. So what do you feel some of the key achievements of the CHIPS program, and then we'll go into some of the misconceptions later.
Yes. So I mean, we can measure the CHIPS program achievements in a different ways, in terms of the job creation, in terms of the technologies it brought, in terms of economic stimulus, the FDI. If we look at it from the purely the technology point of view, before the CHIPS Act, after the CHIPS Act, I think our leading edge production will increase by 200% or so, and probably we will also double the mature node capacity. But beyond the fabrication, there is a downstream ecosystem. As you know, thousands of companies are involved in this supply chain. So we are building, I think probably in 30 years or so, the first time a 300 millimeter wafer fabrication plant over here, and also we have 2.5D and 3.3D packaging expansion. So we have from Intel, Samsung, SK Hynix, so we can package the most advanced memory in the world over here. But beyond that, there is a very large range of technologies, the photonics, the compound semiconductor, and big companies and the small companies has been funded throughout this value chain. So the impact, I think it will be a long-term impact that we will see from the CHIPS Act, is that we will have more companies down the streams relocating when large companies such as TSMC and Samsung and other companies, they expand. So their suppliers, the material suppliers, they will also start looking at US. So that's what, if we can think of the technical advancement that CHIPS Act is bringing.
Yeah.
But similarly, in terms of the FDI, it has brought in like about $400 billion FDI on a $40 billion investment. Plus, it's generating 2-3 times the economic stimulus for every dollar that is being spent. So we can measure it in terms of the job creation per dollars, or we can measure it in a different way. But to me, it looks like a very successful execution of the industrial policy.
Okay, what do you think are the misconceptions about the CHIPS program? I mean, one of the things I think is everybody just talks about the big deals, but there's a lot more to it, isn't there?
No, there is. So I mean, I read these comments often, and so does my colleagues, where there is a conception about this program is a welfare to certain companies, or this program is only for big companies. And sometimes the people, I have read the comments that decisions are premeditated. Being inside the program, I can say it is nothing of like that. So there is very small companies, startups that has been funded to the program. So every project, so there is probably 800, somewhere between 800 and 900 application into the program. Every project goes through the same metrics, same analysis. So every team, so the teams are made of senior director, investment principals, analyst, and the team prepares their own business case. They go very deep into the company's business strategy, and their corporate strategy. They prepare their own business case. They have their own, I would say, market model in terms of the supply demand. So they look at every project through the commercial success of the project, technical success of the project, what it does for the national security, what it does for the workforce. So we call it, this evaluation criteria. So the team goes through every application, whether it is a small company or a big company. An example is there are small companies being funded. For example, I worked on SK Hynix subsidiary Absolix. That was $68 million award, which is a smaller award.
Yeah.
But here there is a company here in California where we're sitting like a few miles from here, Akash, which is again a startup type of a small company. And we have seen very small awards given to the companies, medium size and the large size. I mean, the team has done an incredible job. It was privilege to be working with that team, and a rare privilege to work with hundreds of companies and understand their business strategies. So in terms of if we see that out of 800 and 900, how quickly that team is working to evaluate this in a very objective fashion.
Okay, I mean that all sounds very good. The thing I think also as a result of your role, but also your background in the semiconductor industry for the last 20-25 years, what are the key trends that you've seen, not just over the years, but also from that sort of intense program that you've been involved in the last couple of years?
Yeah, I mean, this is very interesting that you asked me the semiconductor trends. I have followed this industry and just like you, and I have not seen such a massive build out. The last build out we had that was justified, or that was prompted by the iPhone, because we were carrying one laptop and then we started carrying a phone or two phones, right? So that increased the market TAM by 100%. So that doubled the market. And since then it has been a gradual CAGR driven by high performance computing, by the automotive. So if we follow that trend, then this build out looks excessive, but again, having this rare privilege that of interacting with the very senior technical leadership of a broad segments of economies, the hyperscalers, the automotive, and they made us smart in terms of what new services they are thinking about it, what their new evolving technical requirements are. So listening to those people, I think we are going to reach the semiconductor market size of $1 trillion sooner than what we think. And before this, so essentially this AI is really driving the innovation. The compute that's required is immense, and that is driving this investment. The hyperscalers, they are doubling their data center capacity, and this is something that the AI services that they are looking that are going to come out in future. I think they cannot afford not to invest. On the one side, they might lose in terms of building the capacity if those services do not materialize, and they might lose the investment. But if they don't do this investment, they can lose the big time if those AI services materialize. And that is driving this semiconductor content growth, and that is where this is behind in terms of the capacity expansion we are seeing. But the innovation that's required of the ecosystem is across through the full stack, from the chip design, from the manufacturing, from the materials, from the packaging, from the cooling, all through the ecosystem we are seeing this innovation. So in terms of the semiconductor growth trends, they are secular, and the innovation required to make sure that we can do this computation in the energy envelope we have, and we can do it sustainably, that is driving. Another is autonomous driving, that is driving because we need around 1,000 TOPS for a car to achieve level 5 autonomy. And then in terms of the industrial and IoT, the smart manufacturing, we need more AI at the edge, since the decision making, the latency involved for sensors to make a decision, it has to be done at the edge. So that is driving the semiconductor content growth. Having said that, that industry will achieve having said that, there is this the economical way of building out the capacity. So there are companies who understand their customers really well. Their capacities are already sold out, and then there are companies who are thinking, because there is so much incentives available around the world, and not all the build out is economical. So we have seen a lot of build out happen in China, and similarly we are seeing the packages from India, Europe, Japan, everywhere. So the companies have to make this decision, and sometimes those this is again 20-year types of decisions. So we are making it very attractive in some parts of the world by having very large subsidy, like 70% in some part of the world. So that is very tempting for the companies, right? So if I were to borrow Alan Greenspan's irrational exuberance comment, maybe we might see that some of that, not in the most cutting edge technology, those companies they know, but in other technologies we might see that we might see an overbuild.
Yeah.
That might lead to some pricing correction in that part of that semiconductor, especially where it is not so cutting edge.
Yeah. I mean, we're talking about N-1.
Yeah. So another thing that you asked me before was about the misconception about the CHIPS program.
Yeah.
So I've seen I read some of the comments from people that we don't have 2 nanometer here, or we don't have the whatever the nanometers are, but we require for the high performance computing ecosystem for the data center normally do not require the latest and the greatest. I mean, for example, NVIDIA's Blackwell is not the latest and the greatest. iPhone is the 3 nanometer, and the Blackwell is not 3 nanometer. Similarly, the compute and the networking chips, they are not latest and greatest. And if we look at the storage controller, hard drive controllers, they are not latest and greatest. So even without having access, even without having, let's say, 2 nanometer here, we can build out the high performance computing ecosystem, and we can take care of the critical infrastructure.
Got it. Yeah, that's I think that's really a good point. Let's move a little bit forward. If there was a CHIPS Act 2, and I know in EE Times we've written about some of Secretary Raimondo's comments about maybe potentially there needs to be one, but if there was one, what do you think it might look like?
Yeah. So if there was a one, CHIPS Act 2.0, I mean, I think you would agree with me that this industry is, the supply chain is very long and intricate, and I don't think we have gotten all of the supply chain here. It's a long-term effort. It's not a short-term effort, and it will require much more. So, and that there is a limited amount of funding available. So I would say we got into the semiconductor manufacturing itself, but down the streams, for example, we are still reliant on for substrate, we are still reliant on Asia. For PCB, we are still reliant on Asia. For connectors, we are still reliant on Asia. And so if we go down the supply chain, similarly the equipment is where it all starts. Without the equipment we cannot do it, and we didn't, so we probably need to look at equipment, because they are very I would say fundamental in the semiconductor innovation. Whether it's a reticle size or whether it's a geometry of the transistor, they are very fundamental.
Yeah.
And the equipment companies, they are doing some capex in Asia as well. So that might become a point of concern down the stream. And similarly, if we go down the material, so as we were speaking before about the semiconductor trends, the materials are becoming very critical. The way the materials are now being explored and designed, so they are being very critical. So we need to get more of those advanced material here. Advanced packaging, that is very much dependent on the purity of the chemicals.
Yes.
So that used to be a commodity, but because of this AI requirement, that system level requirement, so those are very innovative things. So if we have chips 2.0, and then we also have to see how the memory evolves. That used to be a commodity, now it is a crucial piece of the solution. in terms of whether it is the thermal budget of that high performance computing or it is the computing itself. So memory is now the bottleneck. So I think so these things, if there is a CHIPS Act 2.0.
Well, I mean, that leads us to the next question, and I know this is all speculation, but what do you think the next administration might do? And maybe there are some solid things which are already in place.
Yeah. Well, that is very hard to speculate what the next administration might do. But one thing, looking at the macro picture, I think the whole world realizes the importance of the semiconductor.
Yes.
And importance of having access to it, importance of controlling it, and I think the next administration is also very well aware of the semiconductor technology and its importance for the national security.
Yeah.
So I don't think it's going to go away, the focus on semiconductor.
Right.
And how do we achieve that? That might be, we can use our buying power. We are probably the largest buyers, and our ecosystem is R&D ecosystem is very vibrant. So we can use our strength to attract the companies over here, or we can keep on with the incentives, right? So that's to be seen what approach the next administration will take. So other things in terms of, we have some of the, as we read the news, some of the large deals are finalized, some of the deals are, will be negotiated in the next administration. I think now the companies might have to, hurry up to close as many negotiations as possible. The focus, different administrations have different focus in terms of the environmental regulation, in terms of, social welfare policies. So if that focus changes, then we have different type of deal that will be consummated from what we started.
Okay. We can't go without, like, the big news over the last few weeks has been Intel, especially with Pat Gelsinger stepping down. What do you think about the Intel situation? I think there's more to it than the CEO.
Yes. Well, Intel, for my position as an ex-employee and my position in DOC, I cannot speak very broadly about any company, but I think being on the other side of a table as a customer of Intel in one of my employment, what I feel is that we need to have multiple sources for many different reasons. So the strategic importance of having multiple supplier, that I think everybody will agree that we need to succeed. As a country, we need to succeed. This company needs to succeed. Now, but this industry, or especially the manufacturing, is very capital intensive. Even the R&D, it takes billions of dollars.
Yes.
To be successful, and for that we need volume, right? So number one, company has a lot of volume to run millions of wafers, and so there is potential of collaboration between number 2 and number 3 advanced manufacturers, whether it's on the R&D side or some sort of JVs, or so there is a potential. And also there is a potential between the tier 2 foundries, which are playing mostly in the mature nodes.
Yes.
So they need access to the FinFET technology, and Intel needs access to the the foundry know-how, the customer channel. So there is a potential of those companies working together. So it's possible that we might see some sort of consolidation in the industry on that.
Consolidation or more collaboration, I think.
So yeah, that's a good point. Consolidation or collaboration, as we have probably seen some of the news that few companies were trying to buy Intel, that's a consolidation.
Yeah.
So collaboration or consolidation is going to depend on also the change of control terms in the CHIPS Act,
in the funding,
in the funding, and the team over there have done a great job of making sure that the company is going to spend money for the manufacturing expansion. The money is not going to the shareholders, or the company cannot sell off the assets. So really making sure that taxpayer dollars are protected.
Okay.
But still, some sort of collaborations and JVs are possible. where Intel takes some majority stake, other company takes some minority stake, but that's essentially a form of consolidation that you have, one foundry player instead of two foundry player becoming one foundry player, but more or towards the collaboration.
And so Sanjay, all that aside, you've been involved in lots of different things. What excites you now? What's 2025 going to be like for you in terms of what you want to do, or what do you see as exciting in the industry?
Yeah, I think this industry always have been exciting for me, but for last I would say decade or so, it was about the software as a services, and we have seen a lot of investment. So lucky for people like you and me, the focus on the semiconductor is back, and now even the big money player are looking into the semiconductor, and I see Sequoia's and Kleiner Perkins, and those names are back in the semiconductor. So the innovation that that ecosystem is driving, so that really excites me. And I think this used to be an industry where we are not able to attract talent. That is still a challenge. However, we see that the excitement around the semiconductor industry, so and the innovation that is up and down in the stack, so that keeps me going every day.
All right. Well, Sanjay, thank you very much.
Thank you for the opportunity.
Okay.